Hello and welcome back. We now discuss question number 5 from exercise 8.4. The question says a car firm has 2 cars which are hired out day by day. The number of cars hired on a day follows Poisson's distribution with mean 1.5. Find the probability that no car is used on a given day. Some demand is refused on a given day. So here we have been given that there are 2 cars, right? And the number of cars hired followed Poisson's distribution with mean 1.5. So here they have given the mean value. Mean, that is M. This is 1.5. Now suppose X represents the number of cars demanded. Okay, now the first case is no car is used on a given day. That is, the demand for cars is 0, right? Now, in order to find that, we use the formula for P of X for Poisson's distribution. We know that it is equal to e raised to minus m into m raised to x upon x factorial. So the first case is no car is used, right? So probability of no car being used is equal to probability of x equal to 0. So there is no demand for the cars. So let us obtain this value. So we just substitute all the values here. E raised to minus m, that is e raised to minus 1.5 into m raised to x, that is 1.5 raised to x, x is 0, divided by 0 factorial. So this is the first case over here. Now e raised to minus 1.5, the value is 0.2231. So let us substitute here. 0.2231 into 1.5 raised to 0 is 1. 0 factorial is also 1. So basically the final answer what we get here is 0.2231. So this is the first case. The second case here is some demand is refused on a given day. Probability that some demand is refused on a given day. Now the demand would be refused if demand exceeds 2, because we have only 2 cars. Basically we have to find probability of x greater than 2. That is, if the demand is for 3 cars or if the demand is for 4 cars or for 5 cars and so on. Now in order to find this, what we do is we subtract 1 and the remaining probabilities, that is before 3. The values before 3 would be 0, 1 and 2. So 1 minus probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So please remember, some demand is refused only if the demand exceeds 2 cars, right? And this could be easily obtained as 1 minus P of 0 plus P of 1 plus P of 2. Now we obtain the 3 probabilities and perform this subtraction. So we have 1 minus e raised to minus m, that is e raised to minus 1.5 into m raised to x, x is 0 for the first case, divided by 0 factorial, plus e raised to minus 1.5 into 1.5 raised to x, x is 1, divided by 1 factorial, plus e raised to minus 1.5 into 1.5 raised to 2 divided by 2 factorial. Now we could take e raised to minus 1.5 as a common factor. Now 1.5 raised to 0 is 1, 0 factorial is 1 plus 1.5. Now 1 factorial is 1. 1.5 square is 2.25. 2 factorial is 2. So let us simplify this and let's see what we get. So we have 1 minus e raised to minus 1.5 into 1 plus 1.5, and let us divide this by 2. 2.25 divided by 2 gives us 1.125. 1.125. So we have 1 minus e raised to minus 1.5 into plus 1.5 plus 1. So that's 3.625. This total is 3.625. And we have the value for e raised to minus 1.5. The value given here is 0.2231. Okay, so here we have 0.2231 into 3.625. So if we perform this multiplication, 0.2231, so that's 0.8087. Okay, so 1 minus 0.8087, and if we subtract 1 minus 0.8087, 0.8087 gives us 0.1913. 0.1913. So this is the required probability value.